Hello and welcome to Startup Hack. Today we are going to talk about authentication and authorization in ASP.NET Core. So let's jump right in. Make sure to check out the link down below because we always provide the code samples that you can pull down and follow along so you can see in our project. Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started. Alright, before I need to discuss the main concept and terms. Authentication, simply it determines who a user is. Authorization, simply it determines what a user is allowed to do. Every action pertaining to authentication or authorization in ASP.NET works within the bounds of an authentication scheme. Even when you do not explicitly specify an authentication scheme, the system still operates using the default schema, and every scheme requires its authentication handler by its own authentication handler, implements IAuthenticationHandler, and it is very simple and responds mostly for authentication, while a concrete implementation may involve more logic. For example, the most common cookie authentication handler, apart from authentication, handles also sign in and sign out, but everything has its time. First of all, I am going to show you this simple authentication code. So here's the example. This code is designed to be straightforward and minimal, providing basic configurations for working with authentication and authorization. It defines a simple and insecure login endpoint within a pre-configured default principal as well as a basic logout endpoint logout. So additionally, it includes two action auth and requires no authorization, no auth, does not and both try to return the current context using name or no user otherwise, except for one difference, but I would talk about it later. You may notice that I am using explicit scheme name, but isn't mandatory in actions such for better clarity. So here's example. Okay, now authentication. To begin our journey, let's create our own authentication handler. So here's example. For better transparency, for now it reads our user from the custom header. And to make it work, we need to change the authentication registration. So here's the example. Alright, sign in and sign out. First of all, let's change our handler to read user information from a cookie instead of the header, just because it makes it easier to test in a browser. So here's the example. To make our handler to be able to handle sign in and sign out, we need to inherit and implement IAuthenticationScheme sign in handler and IAuthentication sign out handler, but I would inherit from sign in authentication handler options abstract class, which is nothing else as a wrapper for both interfaces. Here's the example. And of course, we need to add endpoints to use them. So this is we have integrated in our program.cs file. There's one more thing that is done by authentication middleware. On every request, it tries to delegate request handling to a scheme. So this code, your handler can even handle the request on its own. For example, we can handle our sign in and sign out logic inside our authentication handler. All that we need to is just to implement IAuthentication request handler. So here's example. Okay, now authorization. The next crucial aspect that comes into play is authorization. Unlike authentication, authorization is bound to the authorization policy, which in turn references one or more authentication schemes and incorporates requirements. Requirements are the rules that are applied to the user principal. While there are built-in requirements available, we also have the flexibility to create our own regardless of the mechanism used, such as using the controller action authorization attribute or require authorization in minimal APIs. It assigns authorization metadata to the endpoint. This metadata is then utilized by authorization middleware. You have already witnessed how the auth endpoint returns for a one authorized status code. Now let's delve into what actually happens behind the scenes. First and foremost, we have the registration of policies. So here's the example. So as you can observe, we have the default policy and another one
call express scheme policy when you assign a policy to an endpoint. For instance, with required authorization explicit scheme policy, the authorization middleware fetches this information from the endpoint metadata. Subsequent step involves authentication. Yes, you haven't missed it. Authentication plays a role. As you may recall, the authentication middleware only works with default scheme. However, our policy may be assigned to different authentication schemes. Therefore, it appears that we need to enforce authentication with the appropriate scheme to apply authorization for a valid user principal. So here's the code for implementation of iPolicy evaluator. Based on the code, we can understand that it is authenticates each scheme individually and combines them into a super user principal, or returns no result if authentication fails. If no schemes were assigned for the policy, it relies on the result of the authentication middleware. Once a super principal is obtained, authorization rules need to be applied unless the endpoint allows anonymous access. So based on the result, authorization middleware result handler may delegate schemes to challenge or forbid a user. Here's example. The code lays down under the iPolicy evaluator. In simpler terms, authorization.authorizeAsync triggers the authorization handler for each registered requirement. It will succeed only if the requirement was handled and none of them fail. To gain better understanding, let's create our own authorization handler. So here's the example. Edit default policy. Here's the example. And also we need to add the following: our demo authentication handler to be able to test our requirement. So here's the example. I have added plain requirement, which is inherited from IAuthentication requirement, and plain requirement handler, which is linked from our authorization handler plain requirement. So when we call context.succeed requirement, it removes that requirement from the pending requirements collection. However, the question arises, why do we need fail called? If we rely on pending requirements, the answer is quite simple. You may have multiple authorization handler instance for each authorization requirement. One handler's success is satisfying the requirement will remove it from the pending collection, but it can still fail in another handler. The final result will be considered a fail. Final code for all classes program.cs. Here it is. Okay. Our demo authentication handler is this, having all the things. Okay. Deny with user requirements is this. Plain requirement handler is this. Plain requirement is this. When I run this application, I am using first of all login command. And it is logged in the user. Then I am using auth expert scheme, so it is giving me the test user, which is I have already set it over here. So our application works. Thank you for watching this video. I hope you learned the concept of authentication and authorization. So don't forget to subscribe our channel and hit the bell icon for latest updates.
To joining our course, you can simply go to our website called startuphack.com. Thank you.